So what can we do with all the information we've learned so far in organic? And we can transform from one functional group to another. We can add carbons from what we've learned. So we're going to talk for a few pages worth on synthetic strategies of what do we need to do to change a functional group around. And the first thing we want to look at is there a change in the carbon skeleton? And if there is, then how would we go about doing that? And then the second one is there a change in the functional group? Or what is the change in the functional group in the molecule? How can we go about doing that? So back in Org 1, we talked about the conversion of alkenes, alkynes, and alkanes. We can go from an alkyne to an alkene with either hydrogen, palladium, barium sulfate, and quinoline, or sodium and ammonia, depending on if we need the cis or the trans alkene. Okay. From the alkene, we could just add hydrogen and platinum, and we could reduce it down to the alkane. If we need to go from the alkane, remember the alkanes are very unreactive. There's really very little we can do with an alkane. We can burn it, or we can brominate it. So the only way we can really functionalize an alkane is to brominate it and then do, the best case, an E2 elimination to make an alkene. And then to go from an alkene to an alkyne, we have to brominate it to put 2 bromines on and then do 2 E2 eliminations and then add water, and we can get the terminal alkyne. Okay, those are all reactions we talked about way back in Org 1 in the 4th section. So we need to remember those. And the neat thing about organic is it all builds on top of one another. So as we're going along, we need to keep track of what we have learned. So how can we go from a carbonyl to an alcohol? We can reduce it with lithium aluminum hydride or sodium borohydride, followed by water. And from an alcohol to the carbonyl, we can use chromic acid, we can use PCC, or we can use a Swern oxidation. PCC and Swern oxidation just give aldehydes and ketones. A chromic acid, the sodium dichromate and sulfuric acid, gives us ketones and acids depending on what kind of alcohol we're starting with. We've talked about this on the previous video for this. And then from the carbonyl, we can do all sorts of things with a carbonyl. So we have to think back to what we've learned, and we have to remember all the things we have used in the past as part of our toolkit for what can we do with things as we're going along. So if we had a primary alcohol, we could convert it to an aldehyde with either PCC, pyridine, HCl, and chromium 6 oxide, or Swern oxidation to give us the aldehyde, or from the aldehyde we can reduce it with LAH or sodium borohydride back to the alcohol. Okay, much like we talked about on the previous one where we had the secondary alcohol. So we can do either way there, and then from the aldehyde we can do lots of things to it. So if we have an alkyne, we can reduce it to an alkyl halide, an alkene, an alcohol. We can reduce an alkyl halide, an alkene, or an alcohol down to an alkane. We can oxidize an alkane and get it up to an alcohol, an alkene, or an alkyl halide. We can oxidize any of those up to an alkyne, a ketone, or an aldehyde. So as we're going along, kind of covered up the oxidation word. As we're going along, we need to keep track of which way are we going. Are we oxidizing something? Are we removing hydrogens, or are we adding hydrogens, reducing something? Okay, so make sure as you're going along and talking about things, talk about it in the right way so you keep track of which way it's going. So here's a map of a lot of the different reactions we can do. Starting with an internal triple bond, we could reduce it to a double bond. Okay, if we use hydrogen, palladium, barium sulfate, and quinoline, we get the cis alkene. If we use sodium and ammonia, we get the trans alkene. Just depends on which alkene do we need. We can reduce the alkene to the alkane. We can brominate the alkane to make the alkyl halide. We can do an SN2 or an SN1 on an alkyl halide to make an alcohol. We can turn an alcohol into an alkyl halide with either a strong acid, HCl or HBr, or thionyl chloride, or phosphorus tribromide, or we could take the alcohol, make the tosylate, and then do the SN2 with whatever nucleophile to get the alkyl halide. We can reduce a ketone, do an alcohol with LAH or sodium borohydride, or we can oxidize an alcohol to a ketone or an aldehyde with chromic acid or PCC or the Sorin oxidation. From the triple bond, we can make a ketone or an aldehyde, depending on which reagent we need, with this mercury sulfate or the borane. We can go from an alcohol and do either an E2 or an E1 to make the alkene. We can go from the alkene and make the alcohol, either with acidic water, the hydroboration, or the mercury acetate reaction. Okay. We can go from an alkene with either HBr or HBr and a peroxide to add an alkyl halide. And we can go from the alkyl halide with an E2 to the alkene. So all of these reactions are ones we've covered. And yes, I know the page looks scary, but you have to remember all of the things we've learned in the past and what we can do with all of them. So here we have the following reaction. How do we go from an alkene to a ketone in this? Okay. So if we look at the possible functional group interconversions that we have on this page and start with the alkene, which is here, how can we get to the carbonyl? Okay, we can either go to the alcohol and then oxidize the alcohol, or we can go to the alkyne and then make the carbonyl, depending on which way we want to do it. Both of those are ways we can go about doing that easily. Okay, so we can do option A, then H. We can do F and then G. If we really want to go the long way, we can do D to make the alkyl halide, then E to make the alcohol, and then G to make the carbonyl. Or if we really want to go the long way, we can make the alkane brominated, do an SN2, and then so forth. So there's lots of different ways to do these. There is not just one right way. So as you're looking around, keep track of the reagents you can use, the reagents we've talked about, and use those in the correct way to make whatever you need to make. So if we had this, one of the shortest ways to do it would be to brominate it, which would give us the 2,3-dibromobutane. Then excess sodium amide would make the terminal acetylide. We add water to that, and we get the terminal acetylene. And then that, since we want to go from the terminal acetylene to the ketone, we would add the mercury sulfate, sulfuric acid, and water, and we'd form the ketone. Okay. The only way we can go from an alkene to an alkyne is to brominate it, do 2 E2 eliminations with the strong sodium amide, and then add water to make the terminal acetylene. Okay, that's the only way we can do that. So another way we could do this, lost a positive charge in the notes there, is we can take the alkene, if we don't have to worry about rearrangements, and add acidic water to it to make the alcohol, and then we can oxidize that alcohol with our oxidant, the chromic acid, to make the ketone. And we can do it the easy way that way. Right? So now we go into a problem where it's a different style of problem, in that it tells us we can start from any carbon-containing compound with 4 carbons or less in this problem. So we have to look at the problem and see where do we have 4 carbons or less in a chain that could be put together. So we see 4 carbons there, we see 4 carbons here, and then we see 4 carbons containing the oxygen. So this is going to be a couple of reactions where we have to form a carbon-carbon bond, and the only way we can form a carbon-carbon bond, we have said it in class, and we'll say it here, is adding a Grignard or an alkyl lithium and unless it tells you what you have to use, either one works, adding a Grignard or an alkyl lithium to some carbonyl containing molecule to make an alcohol. If we added it to formaldehyde, we would add 1 carbon on. So formaldehyde followed by weak acid, and we'd add 1 carbon onto the chain and make an alcohol. Okay. Now in this one, just doing this doesn't get everything we need, because we have 3 things that all have 4 carbons or less. So there are ways we can go about doing it. So in this, we could see, since both of these groups are 4 carbons, and this carbon with the oxygen on it, both of those added to, we talked about a couple videos ago being able to take an ester, adding a Grignard or an alkyl lithium to it, followed by acid, and the Grignard adds twice to the ester, and it would give us our desired alcohol in good yield. Okay, so to do this all in one way to do it is this way. We'll do some more of these that gives us more information on the coming pages. So the first one, like this, it tells us we have to start with an ester. So it doesn't leave anything for us to decide. It says use an ester, and to that ester, the only things we can add to it are these reagents. They're the only reagents we have to do anything with. So we have to somehow start with 1-butanol. And what can we do with 1-butanol when we have hydrochloric acid, phosphorus tribromide, and lithium? Well, we can take 1-butanol and we can react it with PBr3, phosphorus tribromide, and we make the bromide. We can take that, add lithium metal, and we can make the alkyl lithium. The alkyl lithium, once we've made it, we can add to the ester, followed by a little bit of acid, and that would give us our desired product. Okay, so in a problem like this, if the problem tells you what you can use, you have to be careful and only use that information. Don't change the problem by adding reagents you want to use. So this one is one way to do that. There's also, we might see it where we started with something very, very small, formaldehyde in this case, and we're given a bunch of alcohols and all the other reagents we need and told to make this alcohol. So we see we're going to have to form 3 carbon-carbon bonds. So we're going to have to start with formaldehyde. We're going to have to take all 3 alcohols, the cyclohexanol, the propanol, 1-propanol, and the 1-butanol. And to all three of these, we're going to have to add PBr3 followed by magnesium. To make the Grignard reagent. And then once we've made the Grignard reagent, we can add a Grignard to formaldehyde. Doesn't matter which one. We can start with the cyclohexyl magnesium bromide. After we do a Grignard, we need to add acid. So that gives us a alcohol where we have formed the bond between the Grignard and the carbonyl. And alcohol we need to oxidize up, so we're going to have to use PCC. That's the pyridine chromium 6 oxide, and HCl. That gives us the aldehyde now, so we're back to a carbonyl. Then we can add another Grignard to that. Another Grignard, MgBr, followed by acid. And that's going to give us now the secondary alcohol. And then that we can oxidize with PCC, which we've written up there already what it is. And then we can do the last Grignard with the propyl magnesium bromide, followed by acid, and that's going to give us our product. So we can do it that way also. So here we have again a review. It's all the reactions that we've covered in Org 1. We've talked about in the beginning of this section of alcohols in Org 2. But can we predict the products for all of these different reactions of what all happens with them? In the first one, we know we had a hydrogen on the end of the alkene, and we have the migration because it's just acidic water. And then the oxygen adds to the most substituted cation. We can form the tertiary one. In the second one, remember, mercury acetate doesn't rearrange, so it adds the oxygen to the more substituted carbon. The hydroboration puts the oxygen on the less substituted carbon of the double bond. Acid and oxygen 18 labeled water, we're going to add our oxygen on the most substituted carbon. It's going to be the oxygen 18 labeled one. It's going to come in from the backside of where the epoxide is. On the sodium hydroxide, we're going to add our oxygen 18 on the backside of the epoxide, and it's going to add in SN2 fashion to the less substituted carbon. So we're going to get the oxygen 18 on the less substituted carbon. Then the peracid makes the epoxide. Yeah, we get both the enantiomers going back, coming forward, but we only have to draw one of them. And then we open that up with acidic water, and it's going to change, add the acidic water oxygen to the more substituted side. So we're going to get the anti-diol. The hydroxide, this is a straight SN2, so it is going to invert the stereochemistry. Because it's going to be the backside attack, so it inverts the stereochemistry, and the H here gives us the syn diol. And we've talked about these previously in these alcohol videos early on, so the mechanisms for them are drawn earlier. If you need to see one, send me an email and ask about it. And we can talk about it via email. Here we review that page we talked about earlier where we have the benzyl chloride, benzyl bromide, benzyl bromide, the benzyl tosylate, and then replacing the tosylate with the bromide, with the cyanide, with the amine, with the hydrogen to make toluene, or with the alkoxide to make the ether. And it doesn't matter what the R is, it can be any alkyl group and it's going to do the same sort of thing. And then we have this page of what can we do with an alcohol. An alcohol with chromic acid as primary alcohol gives us a carboxylic acid. A primary alcohol in PCC gives us an aldehyde, and a secondary alcohol with swern or with any of these three just gives us the ketone. Okay. With the methyl magnesium bromide, if we're drawing the mechanism, the easiest thing to do is erase the magnesium bromide and just draw the methyl. It adds the carbonyl carbon, breaking the double bond. So it gives us the tetrahedral intermediate, reform a carbonyl, that gives us the ketone, and then another Grignard can add in, giving us the tertiary alkoxide. And this is all because we can add two groups to an ester because we have the leaving group of the MEO minus on it that can leave in this process. And then here we have all of the reactions we've talked about here in the transformations and what we can do. So to go from a triple bond to the vinyl bromide, it's one equivalent of HBr. Okay. To make the triple bond, we have to eliminate the primary bromide, T-butoxide, brominate the alkene, and then the amidion, and followed by, oh, that's way too thin, sorry. Followed by acid gives us the terminal alkyne. We can take an alkyl bromide and we can add T-butoxide and make the alkene. We can add acidic water, or we can do the mercury acetate and water, followed by sodium borohydride to make an alcohol. From an alcohol to a ketone, we can do PCC. From an alcohol to the bromide, we can do PBr3. From the alkene to the bromide, we can do HBr. And we've drawn all of these mechanisms. You should be able to draw any of them without any problem. Okay, to make the alkyl lithium, we just add lithium metal. To make the ether from the bromide, we need to have 1, 2, 3, 4, 5 carbons with an alkoxide on it to do an SN2 on the primary bromide. So here, for the alkyl lithium, we have 1, 2, 3, 4, 5 carbons. And we go to 6, so we just have to add 1, so that's a formaldehyde, followed by a wee bit of acid. This is 7 carbons we add, and the oxygen, we're forming this bond right here. So this is where we add an epoxide, followed by a wee bit of acid. And then this one is this bond here. This is our alkyl lithium. So we're going to have to add it to the 5 carbon ketone, followed by acid. And then from the alcohol, we can add the alcohol with a strong base, NH2 minus, to form the alkoxide, and then do the SN2 on a alkyl bromide. To make the aldehyde, it's PCC. To make the carboxylic acid, it is chromic acid. Okay, so those are all the transformations we've talked about in this section. You should be able to write any of those out without any problem. If you have any questions about any of them, feel free to send me an email at dnew@uco.edu, and we can talk about it via email. Okay, so here is the end of the alcohols, and then the next section of this, the last 20 pages of this PDF, go into ethers and epoxides, which react just the same way as what we've done so far. We'll get into a little more detail with them.